All right, so lastly, ladies and gentlemen, on this one is you guys can see that I do not have any variable that has a coefficient of 1, correct? Correct? None of them have a coefficient of 1. So substitution, you can still do substitution, but it wouldn't really be fun because then you'd have to solve for a y or an x. And if you guys kind of visually do that in your head, you guys just kind of, I'll go over this again with you. If you guys kind of visually do that in your head, you can see you're going to have some fractions, and that's probably not going to be much fun to be working on. So the other method, which we call, is elimination. And using elimination, what we're going to do is add or subtract our equations to eliminate one of the variables. So if you look at this, if I add or subtract these equations, if I add these equations, when we say eliminate, we want to get 0 as a coefficient, right? So if I add these, do I get 0 as a coefficient? If I subtract these two equations, do I get 0 as a coefficient for any variable? No. Sometimes that's going to work. But in this case, that does not work. So therefore, I need to go to the next step, which is the hardest one. I need to find the common denominator, or I'm sorry, the common multiple of 3 and 2 or 4 and 3. Now, it's a toss-up. Again, you can solve for x first or you can solve for y first. So, OK, what would you like to solve for, x or for y? All right, so to solve for y, we have 4 and 3. What is a common multiple of 4 and 3? What is the smallest number that they both divide into? 12. All right, would you like to add or would you like to subtract the equations? OK, so there's different ways to do this. So he says to get these, they add 12. These both multiply or divide into 12, correct? So what I need to do is I need to multiply them both so they'll be 12. So here I'd have to multiply that by 4. Here I'd have to multiply that by 3. Now, Kay did say he wanted to add, which I prefer adding. I don't like subtracting. Subtracting, I think, makes mistakes. So if I'm going to add them, if I have 12y plus 12y, that's going to give me 24y, right? So therefore, I need to make one of them negative. Don't matter which one. You just need to make, when you're adding, you got to make sure one's positive, one negative. All right, so now let's go and do the math. Remember, when you're multiplying, you got to multiply everything. So this is 9x plus 12y equals 30. This becomes negative 8x minus 12y, negative 28. Now, I add them. Right? And I can add them because you can see these are exactly the same. One's positive, one's negative. So therefore, 9 plus 8x is just going to be x. That goes to 0y, which is just 0, is equal to 2. So now I got my answer. Okay? Now we know what x is. Now we need to figure out what y is. But the problem, you remember in substitution how nice it was to have y solved, right, to plug the other one in? Here we don't have one solved. So we just have to pick an equation. So Jeremy, which equation? The top one or the bottom one? Top one. Doesn't matter. Pick whatever one. And you could use that one or you could use that one. But obviously, these are smaller numbers. So I'm going to say 3x plus 4y equals 10. I know what x is. 3 times 2 plus 4y equals 10. 6 plus 4y equals 10. Subtract 6, 4y equals 4. Divide by 4, divide by 4, y equals 1. So again, ladies and gentlemen, we have a coordinate point of 2, 1. OK? Now, I'm going to give you guys an example of, you might say, well, all right, Mr. McLogan, that was